Cambridge IGCSE, October-November 2021, Physics Paper 42. Question 1. Figure 1.1 shows a space rocket accelerating away from a launch pad. Figure 1.2 says speed time graph for the first 30 seconds of the rocket's flight. So in this question we are provided with the speed time graph of a first 30 seconds of the rocket's flight. Part A, describe how the acceleration of the rocket changes between the time 10 seconds to 30 seconds. So we need to check how the acceleration changes between 10 to 30 seconds. In order to check the acceleration or describe how acceleration changes, if we have a velocity time graph, we just need to check how the gradient of velocity time graph changes. Gradient of a velocity time graph gives us the value of acceleration. So here, in between the time interval 10 seconds to 30 seconds, we just need to check how the gradient changes. Gradient of a graph is nothing but the slope of the graph. So if you know gradient is slope, we can simply check how the slope changes. In order to check the slope, we can draw tangents at different points of the graph, and we can see these tangents or slopes are increasing. The graph is becoming more steeper. From this we can understand the gradient is increasing. That means the acceleration is increasing. Since it is 1 mark question, we just need to write down acceleration is increasing. Part B, by drawing a tangent to the graph, determine the acceleration of the rocket at time is 25 seconds. So we have to draw a tangent when the time is 25 seconds in the given graph. So let's find out which point represents the time 25 seconds. So we can find out it is exactly the point in between 20 and 30. So this point represent time is 25 seconds. And at this point on the graph, we need to plot a tangent. So here we have to plot a tangent. So the tangent is the straight line passing through that point. So using a ruler, you can draw a tangent, a line passing through that point, and it should be a straight line. Now, as we already discussed, in order to calculate the acceleration, we just need to find the gradient of the tangent at this point. Now, in order to find out the acceleration, we just need to find out the gradient of the graph, and gradient is nothing but the y2 value minus y1 over x2 value minus x1. So here we can find out what is y1 and y2. So y1 is at the starting point of the tangent. What is the value on y-axis? And we can identify y1 is 1000. Likewise, at the end point of this tangent line, you can consider any 2 points on the tangent line as starting and ending. And this is the point y2 I am considering, and that is 1750. So we have y1 and y2. Likewise, we need to find out x1 and x2. So x1 is, we will get 20.5 and x2 is 30. So we have these values, we can substitute, then we will get the acceleration. So in the given space, we should write down acceleration is the gradient of the tangent, and that is y2 value minus y1 over x2 minus x1, and y2 from the graph we have 1750 minus y1 is 1000 over x2 is 30 minus x1 is 20.5. So the gradient of the graph is 79. So we can write 79 meter per second square, as the unit of acceleration is meter per second square. and any answer in between the range 78 to 82, you will get full mark. As it is a drawing, there will be a range given in the mark scheme, and according to the mark scheme, any value between 78 to 82 is correct. Part C, determine the distance traveled by the rocket between the time 0 to 10 seconds. So we have to find out distance from a speed time graph. So here we need to know distance we can measure by measuring the area under the speed time graph. So let's look at the graph again to calculate the area. And the time interval given is first 10 seconds. So we need to calculate the area under this section for first 10 seconds, and it is a triangle. So we can use the equation of the area of a triangle, that is half times base times height, where base is 10 and height is 400. So we have base and height values. We can substitute in the equation of the area of triangle. So area of triangle, since the shape is triangle, half times base times height. We can substitute half times base is 10 times height is 400. Therefore, the answer is 2000 meters. So the distance is 2000 meters. Question 2, part A. State Hooke's law. So we can write Hooke's law states that extension of a spring is directly proportional to the load until the inelastic limit. Part B. Figure 2.1 shows the extension load graph for a spring. On figure 2.1, mark and label the region where the spring obeys Hooke's law. So we have to check the graph and identify which part of the spring obeys Hooke's law. So Hooke's law means force or load is directly proportional to extension. So during this section, the graph will be a straight line. So we have to check the graph till which point it's straight line, and we can see it is almost this much. So till 20.5, till this point the graph is straight line. So we can label and obeys Hooke's law. Part 2, calculate spring constant K. So in order to calculate spring constant K, we can use the equation of Hooke's law, that is force is spring constant times extension, where spring constant we can make as a subject. So we will get spring constant is force or load over extension, or force is nothing but load over extension. Now we can look at the graph and we can find one particular value for load, or we can see when the load is 15 Newton, we just need to find any particular load value. Then we have to see for this load what is the corresponding extension, or what is the value on x-axis. So we will get almost this point, and the value which is on y-axis is extension x, and here the extension value is 107.5. So we have when the load when the load value we already have. When load is 15 Newton, the extension we already got from the graph, that is 100.5. So by substituting this in the equation, 0.14 in two significant figure, and we need to look the units, and we can see the load is given in Newton but the extension is given in millimeter. So the unit will be Newton over millimeter. Therefore we can write the spring constant of this given spring is 0.14 Newton over millimeter. Part 3. The original length of the spring is 120 millimeter. Calculate the length of the spring when the load of 8.5 Newton is applied to the spring. So, we can find what is the extension of the spring when the load is 8.5 Newton. So, we need to again check the graph and we have to identify here the load which is 8.5 Newton, and we can see here two small boxes represent 1 Newton. So, we will get here this is 5 Newton, then next second box is 6 Newton, 7, 8, and this point represent 8.5 Newton. So we can find what is the extension when the load is 8.5. So we just need to extend and find what is the corresponding point on y-axis, and we will get that is 60 millimeter. So the extension of the spring at 8.5 Newton is 60 millimeter, so that the new length or the length of the spring will be its original length or initial length, that is 120 millimeter, plus the additional extension when 8.5 Newton applied, and which is 60 millimeter, which we got from the graph. Therefore, the answer is 180 millimeter. So the length of the spring will be 180 millimeter. Part C. The weight of an object is 4 Newton on a planet where the acceleration of free fall is 8.7 meter per second. Calculate the mass of the object. So we are provided with the weight, that is 4 Newton, and gravitational field strength on that particular planet is 8.7 meter per second square. We need to calculate mass. So here you can use the equation W, weight is mass times gravitational field strength. In order to calculate mass, we can make mass as the subject. So we will get mass is weight over gravitational field strength. We have the values we can substitute. So weight is 4 Newton divided by gravitational field strength is 8.7. So in two significant figure we will get 0.46 kilogram. So the mass is 0.46 kilogram on that particular planet. Question 3. Figure 3.1 shows a collision at very slow speed between two cars traveling along a straight road. Car B of mass 800 kg is moving at 2 meter per second and collides with car A of mass 1000 kg, which is stationary. After the collision, both cars travel in the same direction as the initial direction of car B. Part A. After the collision, car A moves at 1.3 meter per second. Show that the speed of car B after collision is approximately 0.4 meter per second. So in this question we have two cars. Car B is having a mass 800 kg. So we can consider the mass of first car M1 is 800 kg and which was moving with the initial velocity 2. So U1, initial velocity of the first car, we can represent with U1, which is 2 meter per second. And the second car, the car A, which is having mass 1000 kg. So since it is the second car, we can represent with M2. Mass of second car M2 is 1000 kg and which was stationary. So initial velocity of the second car U2 is 0 as it was not moving or stationary. After the collision, both cars travels in the same direction and car A moves with 1.3 meter per second. So we have the final velocity of car A represented by 2. So we have V2, that is 1.3 meter per second, and we need to find out what is the final speed of car B, which we can represent it by V1. So here we can use the principle of conservation of momentum. So according to the principle of conservation of momentum, total momentum before collision must be equal to total momentum after collision. So total momentum before collision is the initial momentum of the first car, that is m1u1, plus initial momentum of the second car, that must be equal to the total momentum after collision, that is the momentum of the first car after collision, that is m1v1, plus momentum of the second car after collision, m2v2. Here we have the important values which we can substitute. So we have mass of the first car m1 is 800 times u1, its initial velocity is 2, plus m2 is 1000 times u2, its initial velocity is 0, which is equal to again m1, the mass of the first car 800 times v1, we don't know, that is the final velocity of car B, which we need to calculate. So we can substitute like v1, plus m2, mass of car A, which is 1000, times v2, the final velocity of the second car, which is given 1.3. Now we have all the values, only unknown value is v1. So we can just make v1 as the subject and we can calculate the value of v1. So by solving the left hand side, we will get 1600 is equal to 800 v1 plus 1300. So we can take 1300 to the LHS. So we will get 1600 minus 1300 is equal to 800 v1, that is 300 is equal to 800 v1. So v1 is equal to 300 over 800, and the answer in two significant figure is 0.38 meter per second. So this is the final velocity of the car B or the first car. Part B, calculate the impulse exerted by car A on car B. So here we can use the equation. Impulse is change in momentum. So the change in momentum, the final momentum of the car A is 1300 and initial momentum of car A is 0 as it was stationary. So the change in momentum is 1300. So the answer is 1300, and since it is impulse, we can write its unit is Newton second. Part 2, state the impulse exerted by car B on car A. The value will be same as the impulse exerted by car A on car B, and therefore the answer is 1300 Newton second. For all action, there will be equal and opposite reaction. Because of that, the impulse exerted by car B on A and A on B will be same. Question 4, part A. A power station uses wind energy to generate electricity. State and explain whether this method of generating electricity is renewable. First, we need to state whether this energy is renewable, and we know that wind energy is a renewable energy resource as it never runs out. So a statement we can write down, it's renewable, and we need to give the explanation. So we can write wind does not run out. Part B, state two energy resources that do not have the sun as their source. So there are three main energy resources. They don't have sun as their main source. And they are geothermal, nuclear, and tidal. You just need to write any two of these energy resources. And this is a very important question we can see in many past papers. So you need to memorize these three energy resources as they do not have the sun as their source. Part C. For each energy resource, state the form of energy stored in fossil fuel. So in fossil fuels, energy is stored as chemical energy. So we can write chemical energy. Water behind hydroelectric dams. So in hydroelectric dams, how it works? Water will be stored at certain height and this water will fall down. So this falling water energy is used to rotate the turbines. That's how the energy produced in hydroelectric dams. So the main reason is the gravitational potential energy of the water as it stored at certain height provides energy. So we can write gravitational potential energy. We need to mention gravitational as there are different types of potential energy available. Elastic potential energy is there. So you should mention gravitational potential energy in order to score full mark. Question 5 Part A. A thermocouple thermometer is used to determine the temperature difference between a mixture of ice and water and liquid mercury at approximately 600 degrees Celsius. Complete figure 5.1 with a label diagram to show how the thermocouple thermometer can be used in this way. So in this question we have to draw a thermocouple thermometer. So first of all, in a thermocouple thermometer there will be two different wires. So first we can connect one wire which should be connected to both containers and you can label it as metal 1 wire. Then we need to connect to a galvanometer or a voltmeter using a different metal wire, and that should be connected to one side to the galvanometer and another side to the other end of the metal 1 wire. So we can see a junction here. Now we have metal 2 wire. These both we can label as metal 2 wire. So here this is a 3-mark question, so you will get 1 mark for showing the junction and 1 mark is for drawing the galvanometer and the 3rd mark is for drawing 2 different wires and labeling metal 1 and metal 2 wires. Part B. State 2 other physical properties that can be used to measure temperature. So one of the physical property we are using in liquid in glass thermometer, we can write here, that is the expansion of liquid. This property we can use to design a thermometer. An example is liquid in glass thermometer. And another factor which changes with temperature is electrical resistance, and example is thermistor. So these are the different physical properties changes with temperature. Part C. State 2 benefits of using thermocouple thermometer instead of a liquid in glass thermometer. So thermocouple thermometer has a large range. It can measure the temperature between a very wide range of temperatures, and even we can measure very high temperatures. These are the 2 advantages of thermocouples over liquid in glass thermometer. Question 6. Figure 6.1 shows particles of a material in which a sound wave is travelling. Part A. On figure 6.1, mark the center of the compression with letter C. So compression is the region where particles will be close to each other or the pressure will be very high. So these points represent compressions. So here we need to mark at the center of the compression with the letter C. So this is the center of the compression where we can mark with the letter C. Part 2. The center of the rarefaction with letter R. So rarefactions are the regions where there is less particles. So these points are rarefactions. Now we have to mark with the letter R at the center. So we can mark here as R. So this point is rarefaction. Part 3, one wavelength with a double-ended arrow. So for a longitudinal wave or sound wave, the wavelength is the distance between one compression to next compression. So this length represents the wavelength of the sound wave. Part B, circle one value from the list which is speed of sound in water. So the first one, 15 meter per second, is too small, and 150 meter per second is also too small for the speed of sound in water. So basically we need to know the speed of sound in air, which is almost equal to 330 meters per second. So this is the speed of sound in air. So the speed of sound in water will be more. So definitely it must be greater than 330. So the possible answer is 1500 meter per second. 15,000 meter per second is a higher value. So all other values are higher. So therefore the correct answer is 1500 meter per second. Part C, the wavelength of sound wave in water is 12 centimeter. Calculate the frequency of this sound wave using your value from B. So we have to use the value in B. So where we know that the speed is 1500. So we can use speed is 1500 meter per second and the wavelength is given. So lambda is 12 centimeter. So we need to convert into meter. It will be 12 10 to the power minus 2 meter. Here centimeter to meter conversion, we should multiply with 10 to the power minus 2. In order to calculate frequency, we can use wave equation, that is speed is frequency times wavelength. So we can make frequency as the subject. So we will get frequency is speed over wavelength, where speed we have provided in previous part, that is 1500 over wavelength is 12 times 10 to the power minus 2. Therefore the answer in two significant figure we can write 13,000 hertz. So the correct answer is 13,000 hertz, or even we can write 13 kilohertz. Part D, state and explain whether the sound in C is ultrasound. So we can look at the frequency, which is 13,000 hertz or 13 kilohertz. So here we need to know that the sound waves in the range of 20 hertz to 20 kilohertz belongs to audible sound wave, and any sound waves which is greater than 20 kilohertz belongs to ultrasound. So here it is something, the frequency that is only 13,000 or 13 kilohertz, which is smaller than 20 kilohertz. So we can write this is belongs to audible sound wave. So first we can state no, this is not a ultrasound, and for the reason we can write down 13 kilohertz is less than 20 kilohertz. Therefore not ultrasound. So any sound, its frequency is greater than 20 kilohertz only, we can say it belongs to ultrasound. Question 7, figure 7.1 shows a ray of light approaching face AB of a glass prism of refractive index 1.5. Part A. On figure 7.1, accurately draw the path of the ray within the prism from face AB to face AC. You will need to make a measurement from figure 7.1 and carry out a calculation. So here on figure 7.1, we have to draw the path of the ray within the prism from face AB to face AC. So in this question, we have to draw the ray after it is passing through the surface AB, in which direction it will go. We have to take the measurement and draw accurately. So the first step here, we have to draw a normal. So normal is nothing but a perpendicular line from the surface AB, from the point where the ray of the light incident on the surface. So from this point, we have to draw a perpendicular line, the perpendicular from the surface AB. In order to do that, we can draw a perpendicular line which should be 90 degree from the surface. Using a protractor, we can draw the normal and we can label it as normal. The next step is measure the angle of incidence using a protractor. So you can keep a protractor here and measure the angle between incident ray and the normal. So this angle is angle of incidence, and if we measure it properly using protractor, we can see this measurement is 60 degree. So we have angle of incidence, that is 60 degree. Now we can measure what is angle of refraction. That is the third step. Measure angle of refraction, which we can calculate using an equation. So let's see what all values are already given. That the refractive index of the glass is given, that is 1.5. So we can write that is refractive index of the glass. Then angle of incidence is given, which is 60 degree. Now we need to find out angle of refraction. So here we can use the equation. Refractive index is equal to sine of angle of incidence over sine of angle of refraction. So we can make sine of angle of refraction as the subject. Then we will get sine of angle of refraction is sine I over n, where we know the values of sine I, that is I is angle of incidence is 60 degree over refractive index 1.5. In order to calculate R, we can take this sine to the right hand side. So the sine will become sine inverse. Hence we can keep R at the LHS of the equation. So when we take the sine to the RHS, it will become sine inverse of sine 60 degree over 1.5. Using a calculator, we can find the answer, and it will be 35 degree. So we have action which is 35 degree. Now we can draw the ray which must be refracting at an angle 35. As we have already calculated, we got angle of refraction is 35. Again we need to take a protractor. Then from the normal we should measure 35 degree using the protractor. Then we can draw a ray which represents the refracted ray. So we have to make sure the angle of refraction, that should be 35 degree using a protractor. And we can include an arrow to indicate the direction of the refracted ray. Part 2. Determine the angle of incidence of this ray when it strikes face AC. So now we have to measure the angle of incidence of this ray when it strikes its face AC. So here, in order to measure what is the angle of incidence at this point comparing to the surface AC, we have to draw another normal. Normal means nothing but a perpendicular line from the surface AC. So, using a protractor, you can measure 90 degree from the surface and that line must be normal. Then we can measure how much is this angle between this normal and incident ray. So if you measure properly, we will get it as 10 degree. So here the angle is 10 degree. Part B, without further measurement of calculation, sketch on figure 7.1 the approximate path of the ray after passing through the phase AC. So again we can go back to the picture and we need to continue this ray. After passing through this surface AC, what will happen? What will be the path of the ray? We don't have to measure or calculate. We just need to draw a rough line. So here we can see the prism is a denser medium and outside it is a rarer medium. So that the ray, this particular ray is moving from denser medium to rarer medium. So it will move away from the normal. So we should draw a ray which must be more away from the normal and make sure it must be a straight line. Using a ruler you have to draw. As I am drawing on the screen, I am not able to use the ruler, but you should use a ruler. And the condition for drawing is this particular part is the angle of refraction should be greater than this 10 degree. Part C, figure 7.2 shows a ray of light traveling with an optical fiber. Complete the path of the ray of light to the left hand end of the fiber. So here, in order to complete the ray of the light in an optical fiber, we should know that the total internal reflection is happening in optical fiber. So all the lights will reflect back and again it will reflect back, and we should put arrows. So this is actually total internal reflection. Part 2, name the process taking place at X. So here all the rays are hitting the surface, are reflecting back. So this process is known as total internal reflection. Therefore we can write the name of the process is total internal reflection. Question 8 Part A, figure 8.1 shows a conducting object A, initially uncharged, held on an insulating stand. The positively charged rod B is brought. So in this question we are provided with a conducting object A, which is a conductor but uncharged. That means it has equal number of positive and negative charges and which kept on an insulating stand. And another positively charged rod B is brought close to the object A, where A is uncharged. Part 1, on figure 8.1, draw the distribution of charges on object A. So here we know as the charged rod, positively charged rod, we brought to this, all the negative charge will come close to the positively charged rod, since opposite charges attracts. So we can represent with 6 negative charges. Therefore, there should be more same number of positive charges at the other side. So here also at the other side there should be 6 positive charges. So you have to make sure how many number of negative charges you are drawing. The same equal number of positive charges you have to draw at the other side, because positive charges will get repelled with the positively charged rod and negative charges will get attracted. Part 2, a wire is connected from object A to earth. State and explain any movement of charge. So now a wire has connected to earth. So what will happen? Therefore in statement we can write negative charges flow from earth to object. So it is because when charged rod B, which is positive, when that touch this conducting objects, all the electrons will transfer to the rod. So there will be excess positive charge in the object A. So the total charge of the object A will be positive. So in order to balance this positive charge, this excess positive, the electrons will transfer from Earth to this object A. So as explanation we can write, electrons flow to balance excess positive charge on the object. Part B. There is a current in a wire of 0.65 milliampere for 2.2 minutes. Calculate the charge that flows. So we are provided with the current and time and we need to calculate charge. So here we can use the equation current is equal to charge over time. In order to calculate charge, we can make charge as the subject. So we will get charge is equal to current times time. So charge is equal to I times T, where I is 0.65 milliampere. So we have to convert milliampere into ampere. For that we have to multiply with 10 to the power minus 3. For milli we should multiply 10 to the power minus 3. So the current will become 0.65 times 10 to the power minus 3 times time, which is 2.2 minutes. Again we need to convert minutes into second. For that we just need to multiply with 60. And the answer is 0.086. So we can write 0.086 into significant figure with the unit of charge is coulomb. Question 9 part A. Figure 9.1 shows a cell of electromotive force 15 volt and a battery of EMF 6 volt connected in series. As we can see, calculate the combined EMF of the cell and the battery. This is a very easy question. One cell and a combination of cell, that is battery, is connected in series. So the total EMF will be the sum of all individual EMFs. So that is the total EMF will be 1.5 plus 6 volt. So we will get 7.5 volt. So that is the correct answer. Part B. The combined resistance of the three resistors shown in figure 9.2 is 4.4 ohm. Calculate the resistance of resistor R. So we have three resistors connected. Two parallel combinations of 2 ohm and 3 ohm is connected in series with an unknown resistor R. And total combined resistors of these three resistors is given, that is 4.4 ohm. So we need to calculate what is the value of unknown resistor. So here first we can find the combined resistance of this parallel combination. Let us represent with Rp, the combined resistance of these two parallel combination, and that is, we can use the equation 1 over Rp is equal to 1 over R1 plus 1 over R2, that is 1 over 2 plus 1 over 3, and we will get, and this answer is 0.833, but this is 1 over Rp. So we can calculate Rp, that is the reciprocal of 1 over 0.83, and that is 1.2 ohm. That means the combined resistance of these two parallel resistors is equal to 1.2 ohm. Now we can consider these two resistors, that is one unknown resistor R is in series with this parallel combination of resistors which we calculated 1.2. Now we have two resistors, they are connected in series. So we can write in series the R combined will be equal to the unknown resistor R plus the R parallel combination which we already calculated, and the R combined value is given, R parallel combination also we have calculated. We can substitute these values. So the combined resistor is already given, that is 4.4, which must be equal to the unknown resistor plus the combined resistance of the parallel combination, that is 1.2. So in order to calculate R, we can make R as the subject. So we will get 4.4 minus 1.2. Therefore, the answer is 3.2 ohm. So 3.2 ohm is the correct answer. Part 2. The current I in figure 9.2 is 0.94 ampere. So the current flowing in this figure in the circuit is given. So we have, there is a current which is flowing and that current is 0.94 ampere. Calculate the potential difference across the combination of resistance. So we have I which is 0.94 and we have the R total or R combined which is already given, that is 4.4 ohm. We need to calculate voltage. So we can use Ohm's law, that is voltage is IR, product of current and resistance, where current is given 0.94 times resistance is also given. The combined resistance of all three resistors is 4.4 ohm and the answer is 4.136. So in 2SR we can write 4.1 volt. Therefore the correct answer is 4.1 volt. In 10 part A, name the logic gate shown in figure 10.1. So this is a OR gate. Part B, figure 10.2 shows a combination of logic gates. Complete the right hand column of table 10.1, the truth table for the combination of logic gates. You may use the blank column for your working. So in this combination of logic gates, we have one NOT gate and a NOR gate. Let us look at the truth table of a NOR gate. So this is the truth table of a NOR gate. Now we can see, as per the table, when the input is 0, what will happen at the output of NOT gate? It will be the inverted value at the output of a NOT gate. So we will get 1. And this 1 we are connecting to both the input of NOR gate. So at NOR gate input we have 1 at both sides. Now we can see, for a NOR gate, when both the inputs are 1, 1, what will be the output? We can see the output will be 0. So in this case the output of the NOR gate will be 0. So we can write it at output, it must be 0. Now we can see, when the input is 1, what will happen? So here again at input it is 1. At the output of the NOT it will be the inverted value. So we will get 0 and the 0 is connecting to both the inputs of NOR gate. So at both sides we have 0, 0. So we can see, when the input is 0, 0, what is the output? The output is 1. So in this case we will get output as 1. Therefore when the input is 1, the output will be 1. It is not compulsory to use the blank column because it's mentioned you may use the blank column. So if you write this answer at the output, you will get 2 marks. Part C, an electrical device has a metal case. Explain the benefits of earthing the metal case. So here we need to mention what are the benefits of earthing a metal case of an electrical device. So we can write, earthing prevent electrocution if live wire touches metal case. Part D, explain how a fuse protects a circuit. So here we can write the basic working principle of a fuse, that if the current in the circuit is too high, fuse melts. Since it is 2 mark question, these 2 points are enough. Part 2, the current in an electric kettle connected to the mains through a fuse is 10 ampere. Fuses with the following rating are available. Circle the correct fuse rating for this appliance and explain your answer. So we have an electric kettle and which will be connecting to a power supply with a current 10 ampere. So this kettle require a 10 ampere current in order to work, or the kettle needs only 10 ampere current. So we have to block any excess current flowing through this electric kettle. So any current which is greater than 10 ampere we should block. So in order to block this, we can use a fuse in this kettle circuit. So we have to choose which fuse is more appropriate. So we can see 3 ampere and 9 ampere or even 10 ampere. If we are using, these currents cannot flow, but we know that in order to work this kettle it requires 10 ampere current. So 10 ampere current should always flow. Therefore we cannot use these fuses. So the more appropriate fuse is 13 ampere, which is greater than 10 ampere current and very close to the 10 ampere current also. So we need to circle 13 ampere and we need to write the explanation. Therefore we can write fuse value is above but near the operating current 10 ampere. This much point is enough to score full mark. Question 11 part A. Describe the composition and structure of a neutral atom of beryllium 8 which has a proton number of 4 and a nucleon number of 8. So we have to describe both composition and structure of this atom. So first point we can write down about the general composition or general structure of an atom, that it has a very small nucleus surrounded by electrons. Then we can mention about the particles inside the nucleus. So we can write neutrons and protons reside in nucleus. Now we can write about the number of protons and neutrons. So as it's mentioned, the number of protons is 4. We should understand number of electrons also 4. The reason is this atom is neutral. Neutral means number of electrons and protons will be always same. Therefore we can write number of electrons is 4. The reason is there is 4 number of protons. So equal number of electrons. So there must be 4 number of electrons. And we can even mention about number of neutrons. So the number of neutrons will be always the nucleon number minus number of proton. So here nucleon number is provided 8 and number of proton is provided as 4, so that it will be 4. So the number of neutron is also 4. Hence we can write 4 neutrons in nucleus. Part B. A radioactive isotope decays by beta emission to form an isotope of barium with nucleon number 135. We are provided with a table with different elements, its symbol and proton number. Use data from table 1.1 to write down the Nuclide equation for this decay. So we can see that in this decay, one of the product is barium. So we can look at barium. The symbol is Ba with a proton number 56. So here we have an element. We have no idea about the element, but after the beta decay, so there is a beta decay. Beta means always minus 1, 0. This one you have to memorize. It produces barium also. So we have barium, and we know that the proton number of barium is given in the table. So here at the bottom we have to write proton number, that is 56, and even nucleon number is also given 135. So at the top we can write 135. So we have an element, we don't know which one, so we can consider it as an unknown X. But we can identify what will be its proton number and nucleon number. So here we need to know that at right hand side of this equation and left hand side of the equation, the neutron number or the proton number and nucleon number should be balanced. So we can see at RHS the total number of protons is 56 plus minus 1, that is 55. So that the total number of protons at RHS is 55. Therefore, at LHS also it must be 55. Likewise, the nucleon number also should be balanced. So here the total nucleon number is 135 and 0. So that is 135 plus 0, that is 135. Now we can find out which element here has a proton number 55. We can look at the table and we can see cesium is the element which has a proton number 55. Therefore, we can write here it must be, this element must be cesium. The symbol is Cs. Thank you for watching this video. If you find this video useful, please like this video and subscribe my channel. Thank you.